So continuing with the 11D notes, we're going to next graph the log function, which should be fresh in your memory from our log unit we just finished. And this is what the graph of the log function looks like. Our anchor point we're going to use right here is kind of the point 1, 0, because all logs go through that point right there. And so we will do this, and we're graphing. I just went ahead and chose to graph log base 2. I think that's probably the easiest one to do. All right, so now what happens? So here we can see the log. So we're going to use the log graph right there, and we're going to translate it. And again, you see here's the parentheses with the x minus inside. So it's going to move right 3 and up 4. So I'm going to take this 1, 0, this point right here, and I'm going to go right 1, 2, 3, and up 1, 2, 3, 4. So keep in mind that there is an asymptote that goes here on the y-axis. So we're going to have an asymptote that goes right next to this, and perhaps that's really what we want to move over, is the asymptote's it's going to move to the right 3. So here you can see the asymptote move to the right 3. There's lots of dots on there, isn't there? All right, so let's just change the colors here and change this and make this our point right there. But you can kind of see how that goes. It's going to go to 1, so it looks something like this, and it's going to follow along the asymptote, getting closer and closer to it, but it looks something like that right there. So the important thing to remember is that there is an asymptote that happens, and that's going to move left or right. In this case, it was right 3, and then we're going to graph the point. Just make sure that point 1, 0 is on there and gets moved and translated. So give that a try here on this next one. Okay. All right, so now we did not ever really graph 1 over x. So again, this is a parent, y equals 1 over x. So let's just take a minute and graph that and see what it looks like. If we plug in a -3, we get -1/3, -1/2, -1. 1 over a -1/2 gives me the reciprocal, so that's going to be -2, -3. And then 1/3, 1 over 1/3 would be 3, 2, 1 over 1's 1, there's a 1/2 and a 1/3. So what happens at 0? If I plug a 0 in, it is undefined, right? So that at 0, that means that nothing happens. There's going to be an asymptote there. So let's just take a minute and look at the graph. We have 3, a -3, I'm sorry, -3, -1/3, right about here, a -2, -1/2, -1, -1, -1/2, -2, and then -1/3, -3. And again, if we were to substitute smaller and smaller numbers, we'd see that it never got positive. It's always going to stay negative, but it's going to get ever closer to the x-axis and the y-axis. So it looks something like that, a smooth curve, not a little wavy one like I showed. Then I have 1/3, 3, 1/2, 2, 1, 1. I have 2, 1/2, and 3, 1/3. And again, I have another like swoop here that's going to swoop along. And these then are asymptotes. So the axes are actually asymptotes that it never touches and the graph never touches and never crosses. And so that's going to be our important part of this reciprocal function. And that's what this is called, a reciprocal function. I'll write that there. And what we're going to do is we're going to move those axes when we translate. All right, so here we go. The x and y axes are asymptotes. We had one of those in the log and exponential functions, which are guidelines for the graph. and we show them with dotted lines. So note that the intersection for this one is at 0, 0. The domain, so if you look at the domain up here, you see on the left I have an arrow, on the right I have an arrow, but the only place, there's one spot that's not ever crossed, and that is at 0. So it is not ever crossed there. So when I do the domain, I'm just going to say that the x will not be 0. And the same thing is also true for the range. Every y is covered except the one there at 0. And so the range would be that y also can't be 0. There's a vertical asymptote at x is equal to 0, and a horizontal one at y is equal to 0. All right, so let's try graphing these. So we talked about how when we move left and right, our number is going to be grouped with the x, and our grouper here is going to be the fraction bar. And if you look underneath it, the x here is alone. So that means it's not going to move left or right, so it stays. The 2 is on the outside, and it's going to move up 2. So what's moving up to? Our intersection of the asymptotes. So I'm going to put a little here, x here, for x marks the spot. And so that asymptotes moved up to, I'm going to draw my asymptotes, which you need to do when you're graphing these. And then the points that we can put in then would be this one here, the 1, 1, and those are the real obvious ones. And since we're not being real picky here, we're going to sketch these graphs here. So there's your 1, 1. Here's your, should be a 2, 1/2 right here, and 1/2, 2 right there. So same thing, -2, -1/2, -1/2, -2 right there. So there is our graph. So this next one, B, this time, here's you see my fraction bar, and you can see how this 3 is grouped in here with the x. So this time it's going to move left 3. So look at the difference between the up 2 and the left 3. So this time, erase that, it's underneath the fraction bar. So what moves? The intersection of the asymptotes, 1, 2, 3. I'm going to go left 3 and make that x. Then I'm going to sketch in my asymptotes here. And then we're going to graph it. So I want the 1, 1, the -1, -1, 2, 1/2, 1/2, 2, -2, 1/2, -1/2, -1/2, -2. Sketch it in. And it looks like this there. And then what happens if I have a -1/x? It is going to flip the function. So it's not moving left or right. So this is staying. So here's my asymptotes. But this time, because of the negative sign, when I have my 0, which is undefined, 1, 1, 2, 1/2, you see we're going to get negatives there. A -1/2 is going to give me a -2. So this time red's going to go over 1, down 1, over 2, down 1/2, and it's going to look like this. So it's going to switch the direction of my graph. All right, so then D, let's see if we have one. This time, here's my fraction bar. And you see the -2 is grouped with the x there. So I'm going to go right 2, and then out alone over here is the 4. So it's going to go up 4. So start with my intersection here, go right 2, up 1, 2, 3, 4. Make an X. Draw your asymptotes in. And then, oops, I think I just moved it on its own. I don't know how that happened. But then we want to sketch our graph in, so we're going to go over one, up one. That moved, so I'm not going to be real picky about it. Down one. And I'm going to sketch my graph there. So I believe that, oh yeah. So then, oops. We want to come down here. So the parent, it looks like this. Here's that intersection right there. So what I'd like for you to do then is try and sketch these next two yourself. The a value equals -1. The y value will be multiplied by -1. That's what happens in the function. And how do the following functions look different than their parent? They're going to be flipped vertically. So here you have an example of the parent y is equal to x squared. And then here you can see rather than going up 1, my y value goes down 1. And rather than going up 2, it goes down 2. So here is y equals a -x squared, and you can see how the function is flipped vertically. And here's the absolute function. Again, in blue, here is the y is equal to the absolute value of x. And in green, y is equal to the opposite of the absolute value of x. So again, instead of going up, the y values go down. Again, here is the y is equal to the square root of x, and then below it, y equals the negative square root of x. And you can see that it reflects vertically. So what happens when we do some moving on that and we have something along these lines with a negative in the front? So we're going to, again, translate. So this is going to go right 3 and up 4. So right 3, up 1, 2, 3, 4. And we're starting with a 0, 0. So we have here, it is a parabola. So typically a parabola then goes here. Looks like this. And so if we have the negative out front, then what's going to happen is it's going to turn, and what went up is now going to come down, and it's going to end up looking like this here. So why don't you give a try then for this next one. All right, so here's an idea of what we're going to have to be doing on our function project. We're going to have to be looking and thinking about a shape that we want to put on there. This would be like the eye that we put in our happy face. And we're going to have to think of which way it moved. Now, I can't really look on here and do this, but I can see on your notes that I went, left 3 and up 4. So this went left 3, up 4. I also take a note that it's got this V shape, which tells me that it's going to be an absolute value graph. So I know that that's what it's going to be. So when I write an equation, I'm going to write that y is equal to the absolute value of x. Now, since it went left 3, I'm going to put plus 3. And then on the outside, it went up 4, so I'm going to put plus 4. And that's how I'd write that equation. Then on this next one, here is our main point. Remember, it's where it makes that twist is going to be our main point for this one. So you may need to look back and recall what this function is. And this was a cubic function, and the parent is x to the third. So note the shape. That's an x to the third shape. And I believe that went, right 1, 2, 3, 4. So right 4 and down 1. So when I come over here to write it, I'm going to write y, then I'm going to put in parentheses, x went right 4, so that's going to be minus 4. I'm going to end the parentheses, and since the parent is x cubed, I'm going to put a third power right there, and then minus 1. C is a parabola, and it's upside down. And it went right 3. Again, we're focusing right there. That's right 3 and up 4. And it's the parabola shape, so we know that the parent is x squared. It's also flipped. So that means it's going to be a negative. Put in parentheses. It went right 3, so that's going to be x minus 3 squared, and then up 4 plus 4. I think I'm out of time. So we'll pick up the end ones at the end. Give them a try.